Here we are, Enriched Algebra 2 students, starting a new unit. We are moving away from graphing, solving, to simplifying rational expressions. So this might be a nice change of pace. Let's see what we've got here. Well, what is a rational expression? Okay, rational, think of fraction. So is 3 a rational number? Sure, because 3 can be written 3 over 1 as a fraction. Is pi a rational number? Pi cannot be written as a fraction. So pi is not rational. So pi is not rational. Okay, 0.3 repeating is rational because that can be written as 1/3. So rational means fraction, expression, or sometimes a rational function. When we graph them, every input has one output. So we think of fractions with a bunch of x's and stuff in the top and the bottom. So big, wacky fractions. Okay, 2 divided by 2 is 1. So let's see here. If 2 divided by 2 is 1, then we get just 3 over 5. We can check our answer by multiplying 2 times 3 and 2 times 5 to double check that it works. Okay, so this is our check. 2 times 3 is 6, 2 times 5 is 10. 6 over 10 reduces to 3 over 5. So it works. You can cross out the 2 over 2. You can reduce those. For example, the 2 and the 4 reduce to a 1 and a 2. And we can reduce the x's. X over x reduces to 1 over 1. So the answer is 1/2. So what I'm arguing is no matter what x is, 2 times whatever number you pick, like 2 times 31, over 4 times 31, always reduces to 1/2, no matter what x is, even if it's 31. Okay, let's move on. Okay, 2 plus 5 is 7 over 2. 2 plus 5 is 7. 7 over 2 is 3 and 1/2. Okay, now we have just discussed the fact that 2 over 2 is 1. And 1 plus 5 is 6. Holy cow, something's wrong. These are different, which is bad. So 2 over 2 is 1, but evidently not always. In this problem, you can't reduce. So how in the world are we going to keep this straight? I thought 2 over 2 over in this problem over here, 2 over 2 was 1. Okay, you can reduce, look on the left side, you can reduce if there's multiplication. You can't reduce. You can reduce when there's multiplication. You can't reduce when there's addition or subtraction. So in this problem, x over x can't be reduced. So the answer is just x plus 2 over x. You can't reduce those because of the addition. Interesting. Okay. So let's give this bad boy a shot here. Okay. So can you reduce this 4 and the 2? No, because of the addition. Whenever there's an addition, you can't reduce it. What about this 2 and the 2? You can reduce it because there's multiplication. So you're left with 3 plus 4, which is 7. Here, can you reduce those? No, because of the addition. So let's give up and say we can't reduce it. But not yet. Wait. Before we give up, let's see if we can change addition to something that's multiplied. How do we change addition into something that's multiplied? Let's try factoring. Factor out an x times x plus 6 over x. All right. Can you reduce these x's? No, because of this addition. Can you reduce these x's? Yes, because of the multiplication. So our final answer is x plus 6. Okay. Here, we cannot reduce those x's because of the addition and the subtraction. But before we give up and say that it's already reduced, let's try and factor. We can factor the top into x plus 4, x minus 4, and the bottom into x plus 5, x minus 4, something like that. Now we have multiplication here, so we can cross out those whole things, getting x plus 4 over x plus 5 as the final answer. Okay, this one, the last one maybe. Here we already have multiplication, so we can just happily start reducing. Divide the top and bottom by 3. X to the third crosses out with 3 of those, leaving an x on top. 2 of these cross out with 2 of these, leaving 3 on the bottom. So we're left with 2x over 3y to the third. Okay, that's a brief introduction to simplifying rational expressions. Easy peasy lemon squeezy. This unit looks like it's going to be no problem.